Logarithmic expressions. Well, now that we know the properties of logs, we can begin to play with them a little bit in preparation for solving problems with them. We're going to have two objectives in this video lecture. Basically a do something and then do the opposite. So objective 1, write a single log as a sum, difference, or multiple of logarithms. And objective 2, go backwards, write a logarithmic expression as a single log. Okay, so we're going to take a single log and write it kind of expanded, take an expanded log and kind of write it as a single log. That's the general idea here. All right, what do we know? Well, we know what a log is, a logarithmic function. Any function of the form y equals the log base b of x, where our base is greater than 0 and not equal to 1, and our argument is positive. And as a reminder, the log function gives us an exponent. Okay, it's the name for a certain exponent. And we also saw in our previous video lecture the properties of logs. I'll go through those briefly here. The log base b of 1 is 0. The log base b of b is 1. The log base b of b to the x is x. And then the product property, the log base b of a product is equal to the sum of the log base b of the sum of the logs base b of the factors. The log base b of a quotient is equal to the difference of the log base b of the numerator minus the log base b of the denominator. And finally, the log base b of x to the nth power is equal to n times the log base b of x. So we saw those properties previously. Now let's play them a little bit. So I've got 4 examples for each objective here, and we're going to want to focus on these because this is what's going to get us to, these are what's going to get us to figure out these, understanding these and having these well in our heads, if that makes any sense. So the objective 1, we want to write a single log as a sum, difference, or multiple of logs. So use the properties of logs right up here to express each of the following, and these are single logs, as a sum, a difference, or a multiple of logs. Okay, so we basically are, generally speaking, we're turning one log into more than one logs, or we're rewriting it as a multiple. Example 1, the log base 3 of 14. Well, I want to make it a sum, a difference, or a multiple, and I can make it a sum if I say the log base 3 of 14 is equal to the log base 3 of 2 times 7. Okay, so 14 is 2 times 7, and since this is now property 4, the log of a product is equal to the sum of the logs of the factors, and so this is log base 3 of 2 plus log base 3 of 7. Okay, example 2, the log base 8 of n to the 5th. We want to write this as a sum, a difference, or a multiple. We can write this as a multiple. So log base 8 of n to the 5th, and we can use property number 6 here. The n as an exponent can come out in front, so the 5 can come out to here. And this is equal to 5 times the log base 8 of n. So now we've written this as a multiple, 5 of these. All right, number 3. the log base 4 of the cube root of x. This one takes a little bit more, just a touch more understanding of what the cube root means and how we can rewrite it. The cube root can be rewritten as a fractional root. So the log base 4 of the cube root of x can be written as the log base 4 of x to the 1/3 power. So this is the exponential equivalent to the root over here. The 1/3 power is the cube root. And now we're back to property 6. We can write it as a multiple. This can come in front. And we have 1/3 times the log base 4 of x. Okay? Let's do one more example. And obviously I've lost my properties, but I can refer to my property because I know them pretty well. Okay, the log base e of a quotient. And note in the quotient I have a product in the numerator. Just for future reference, we learned, I've spoken previously that the log base 10, which is also right down here an example, is called the common log. The log base e is called the natural log. And we'll play with the natural log a little bit in an upcoming video lecture. So for right now, we'll just call it the log base e. Okay, so the log base e of this quotient, x times y divided by z. Well, property 5, I think, the log of a quotient is equal to the log of the numerator minus the log of the denominator. So this is the log base e of the numerator minus the log base e of the denominator. Okay, so we've got this. Now we can go further because this is the log of a product, property 4. The log of a product is equal to the sum of the logs of the factors. So I can take this piece and I can rewrite this as the log base e of x plus the log base e of y. And then we don't want to forget that we also have this piece here minus the log base e of z. So we break this one down. We first broke it down using the quotient rule. And then we saw that in the first log here we have a product. So we broke the first one down using the product rule. Okay, essentially, let's go backwards. Objective 2, we have these logarithmic expressions, and all of them have more than one log, and we want to write them as a single log. Use the properties of logs to express each of the following as a logarithm of a single quantity, as one logarithm. Okay, log base 2 of 3 plus log base 2 of x. Well, if we have a log plus a log, we know that that's the same thing as the log of a product. Again, property 4. So the log base 2 of 3 plus the log, let me get my other notes together here so I don't forget stuff, plus the log base 2 of x is equal to the log, so we're just going backwards with property number 4 of 3 times x. Again, the log of a product is equal to the sum of the logs of the factors. We're just going backwards. And this, of course, I can simplify this a little bit in my writing and just say 3 times x. And there's a single log, a log of a single quantity. Okay, example number 2, log base 10 of 20 minus the log base 10 of 4. And as I just mentioned about 2 or 3 minutes ago, the log base 10 is called the common log. So I will be discussing that in an upcoming video lecture as well, a bit more. We have a difference here of 2 logs. And so we know from property 5 that we can change that into a single log that is a quotient, a division problem. So this equals the log base 10 of 20 divided by 4. Again, the log of a quotient is equal to the difference of the log of the numerator minus the log of the denominator. We just went the other direction. And of course, I can simplify 20 divided by 4. This is the log base 10 of 5. Okay, two more. We're playing with this a little bit. Let's get back into these roots a little bit. The log base b of the square root of x plus the log base b of, x squared. Well, this looks like, this looks an awful lot like this one. We're adding two logs with the same base, and we know the multiplication rule applies. So I'll rewrite the problem. Log base b of the square root of x plus the log base b of x squared is equal to the log base b of the square root of x times x squared. Well, that can certainly be simplified. Let's recognize that x squared, the square root of x is the same as x to the 1/2. So this is x to the 1/2 times x squared. Again, the square root of x is equivalent to x to the 1/2. And now when I have the same base, I add the exponents. So this is the log base b of x. Let's see, 2 is 4 halves. 4 plus 1 is 5 to the 5 halves. And there you have that one. And my last example, it's got a fair amount going on here. 1/2 the log base e, so we're back to a natural log. We're going to look at that later, of a, minus 2 times the log base e of 5, plus 3 times the log base 3, this should be an e. Got a mistake there. That should be an e of x, because I want to have all the same bases. Okay, so what do I know? Well, first off, I can move all of these, according to property 6, I can move all of these numbers in front, and they can become exponents if I do property 6 in the reverse order. So this is the log base e of a to the 1/2 minus the log base e of 5 squared plus the log base e of x cubed. Okay? Now I go left to right as usual. I have a log minus a log. That's a quotient. So this is the log base e of a to the 1/2 divided by, I'll go ahead and do the math, 5 squared is 25, plus the log base e of x cubed. Okay? Now I have a sum of logs, and we know from property 4 that's a product. A product property, I can multiply those two. So this is equal to the log base e of a to the 1/2 power over 25 times x cubed. Okay, and I can simplify that and make it look a little bit nicer. The log base e of a to the 1/2 times x cubed over 25. And if you'd like to, you could also write this as a to the 1/2 is the same as the square root of a. So you could write that as the square root of a2. Either one is acceptable. So there you have it, a fair amount of practice going back and forth with the properties of logs.